So we were in full duplex. In full duplex type of communication, so we share the medium between sender and receiver. So the best example is full duplex communication is telephone network, your mobile network. So these are the examples of full duplex type of communication. So you can see the diagram again. This is the one-way communication. Here, this station is acting as a sender, and this is acting as a receiver, and data is flowing from sender to receiver. This is your half duplex type of communication where this station is acting as a sender for time t1, and this is acting as a receiver for time t2, and this station is acting as a sender for time t2, and this is acting as a receiver for time t2. So one at a time can share this link. So it's just like a one lane road shared by both sides. This is full duplex type of communication. This line is shared between sender and receiver, and both is acting as a sender and receiver at a time. Simultaneously, both is acting as a sender as well as the receiver. So this is all about the data flows. So till now we have seen communication model. This is your communication model consisting of sender, receiver, medium, message, and protocol. Okay. Before that, we have covered. So moving forward to the data flows, we have data representation. So you will find there are 5 different types of data representation or the combination of these data representation. So this is text, numbers, images, audio, and video. So these are called as data representations. You can find text, you can represent your data in the form of numbers, you can represent your data in the form of images or the audio video waves. Now, what do you mean by a text and how it is represented for data communication in computers? So, you will find the text is represented with certain bit patterns. So, each and every character in your text is represented by a bit pattern, and this bit pattern is nothing but the sequence of bits. Now, different sets of bit patterns can be designed to represent text symbols. So, your text symbols each will have unique bit pattern for representation. Each set is called a code. Each set is called as code. And the process of representing symbols is called coding. So, we were using coding method for representing your text. So, today we are using Unicode as our coding system. Here we are using 32-bit to represent a single symbol. So for representing a single symbol or a character, the bits required is 32 bits. And these bits are nothing but the called as a Unicode. So for representing any symbol or any character, 32-bit code is there and called as a Unicode. So any language in the world are using same thing, 32-bit code. The American Standard Code for Information Interchange. This is called as ASCII. Please remember the full form. You may be asked anytime, anywhere. So the American Standard Code for Information Interchange, that is ASCII, is developed in United States and now constitute of first 127 characters in a Unicode. Basically, it is referred in Latin. So these are the nothing but 127 codes. If you are learning C language, there also you have used some ASCII codes, like A in ASCII code is represented by, like if you want to represent A, it is represented by a 65. Okay, so your letter A is represented by a ASCII code or a Unicode 65. If you want to represent B, the ASCII code is 66. And if you want to represent a number 0, because your text contains symbols and numbers also, special character. So 0 will be represented by a 48. Plus sign is represented by a 43. Minus sign is represented by 45. So you can see here, these are nothing but the Unicodes, and these 127 Unicodes total is fixed and used by anywhere in any language. This is called as ASCII, American Standard Code for Information Interchange. Is it clear, students? Students, is it
Yes,
clear?
ma'am.
Yeah. The moving
Yes, ma'am.
forward, the next data representation is your numbers. So what are the numbers? Numbers are also represented in bit pattern. But here we are not going to use ASCII codes. We are going to use a binary codes, that is binary numbers. So codes such as ASCII is not used for representing numbers. Numbers are directly converted to a binary number with a simply mathematical operations. So each and every number is converted into a binary form. Like 1 is converted by a 0 1. 1 will be represented as in binary as 0 1. 2 will be represented as 1 0. 3 will be represented as 1 1. 4 will be represented as like this. Okay, that is 1 0 0. So the screen is visible to everybody? Yes, students?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah. Moving forward to third type is images. Data is represented in the form of image also. So this is a image, you can see here, image of a arrow. Now this is created with the help of many pixels. So you can find here number of rows, number of columns, and in this rows and column the picture is highlighted. So the only pixels are glowed so that your boundary of the image is visible. So this is how the matrix of your images are nothing the matrix of pixels. Each and every small dot is represented as a pixel. So images are also represented by a bit pattern. Image is composed of matrix of pixels. So image is composed of matrix of pixels. And what are pixels? Is a smallest picture element on your screen. Each pixel is nothing but a small dot. So you can see this is a pixel, this is a pixel. So small dots are there. This is also one pixel, this is also one pixel, this is also one pixel. So each dot which can be represented on your screen is nothing but a pixel. So your image consisting of matrix of pixel. The size of the pixels depend upon your resolution of your image. For example, if image is divided into 100 pixels, or it may be divided into a 10,000. So 1000 pixel is a resolution, or there may be a 10,000 pixel. So accordingly resolution is selected. There is a better representation of image, but more money is needed to store this image. So if you represent your first image with 1000 pixel, it will be less costly. If you are representing yours with the 10,000 pixels, it will be more costly. Why? The memory requirement is more to store the each and every details of pixel in your database. So after an image is divided into pixels, each pixel is assigned a bit pattern. हर पिक्सल को एक बिट पैटर्न दिया जाएगा डिपेंडिंग अपॉन वेदर इट इज अ ब्लैक एंड व्हाइट इमेज और इट इज अ कलर्ड इमेज. अगर कलर इमेज है तो आपको बिट पैटर्न साइज ज्यादा लगेगा फॉर रिप्रेजेंटिंग अ सिंगल पिक्सल. अगर वो ब्लैक एंड व्हाइट है तो सिर्फ आपको ब्लैक या फिर व्हाइट यानी सिंगल बिट कैन प्ले द रोल. द साइज एंड द वैल्यू of the pattern depends upon the image. So image is made of only black and white dots. So it is just like a chessboard. You have seen a chessboard, either it is a black or white. So when you play a chess, you can see the board is like a black and white dots. So 1 bit is enough to represent a pixel. 1 bit is enough to represent a pixel. Like 1 pixel, 1 bit, like we have a combination of two, that is 0 and 1. So if you have 1 bit, in 1 bit you can store either 0 or 1. So 0 will be represented by a black and 1 will be represented for white. So whenever there is a 1, it will be represented by white color, and whenever there is a 0, then it will be represented as a black color. Okay. So yeah, this is one example of digital image where the resolution is 6 by 6, means you have 6 rows and 6 columns. You can see here 6 columns. Here you have 6 rows. And total pixels are size is 36. So the memory requirement is 36. Now where to each pixel you will require to store the intensity of the light to be glow. So the intensity value here it's 34, here is 67, like this, and this is nothing but a single pixel. Now moving forward to images, if an image is not made of pure white or pure black, then it is a grayscale. So you can increase the size of bit pattern to a grayscale. Okay. So if we are using 4 levels, you can have multiple levels, 4, 16, 32, any type. So if we are using 4 levels in a grayscale, then 2-bit pattern is enough. Why 2-bit? If you do 2 raised to power 2, if you go for 2 raised to power 2, it comes out to be 4. If you're going for 2 raised to power 2, means it comes out to be 4. So 4 different color levels you can use. And those color levels are 0 bit will be used for black pixel. Dark gray you will represent with 1 bit pattern. Light gray you will represent with what you can send 10. And white pixel you will represent with 11. That is 1 1. So here are the combinations like 0 0, 0 1, 1 0, and 1 1. So total we have 4, 2 raised to power 2, 4. That's why we require only 2 pixel. To 2-bit pattern is enough to store this. So 0 0 for black pixel, 0 1 for gray, 1 0 for light gray, and 1 1 for white pixel. Similarly, we will see for the color images. So color images, here each and every pixel is represented by RGB, that is red, green, blue combination, or YCM, that is yellow, cyan, and magenta. So there are several methods of representing color images. You can see the first method is called as RGB. So called because each color is made up of combination of 3 primary colors, that is red, green, and blue. The intensity of each color is measured and bit pattern is assigned to it. The another method is YCM, that is where each color is made up of combination 3 primary colors, yellow, cyan, and magenta. So you can see here, if this is a pixel green, you can see here, it will be represented as like column is 1 and the row is 0. So 1 0. The red intensity is 6, green intensity is 250, and blue intensity is 7. So the combination of these intensity will be represented by this pixel. So you can see another example. This pixel is represented by red of intensity 241, green color intensity 252, and a blue color uh, intensity as 23. Similarly, we will see next pixel. This is a white pixel, and the intensities of 3 basic colors are given here. You can see here. So accordingly, So as many colors we are using, that many bit patterns are required. So the size of the matrices will be increased. So matrix size will be increased because the single pixel representation bit will increase if you go for color images from the black and white images. So is it clear? Yes, students, is it clear?
Yes, ma'am.
Now,
Yes,
next
ma'am.
we have seen audio video. So audios are represented just like your waveforms. So audio refers to the recording or broadcasting of sound or a music. So audio is by nature different from your text representation, number representation, or images representation, because your voice is nothing but, you can see here, it's a sinusoidal wave with a different peak values, amplitude you will find different. So it is have certain frequency, certain amplitude, and certain phase angle. You have learnt it in a physics. So audio wave is a continuous wave. It is not a discrete, it is just like a sinusoidal waveform. So even when you use our microphone, just now I am using my microphone to change the voice or music to an electric signal. We create a continuous signal. So my voice is converted into a electric signal, and then it is coded into a bit pattern in your computer, and through a transmission medium it is reaching to you. So how this is going on, that we will study in your third unit, where we are studying signals. So exactly how it is happening and coding into a 0 1 format bit pattern, that we will study in third and fourth unit, which is very important. Similarly, your videos. So video refers to the recording or the broadcasting of pictures or the movies. So video can be either be produced by a continuous entity like your TV or a camera, or it can be combination of images. So each with a discrete entity arranged to convey the idea of motion. So if the images are displayed you one by one in your persistent of vision, so it will be look like a moving thing. Okay, so that's why your videos can be represented with a continuous entity or with a discrete entity like images, which are arranged to convey you the motion. So you can see like this, you can have your video signal. So video signals will be like this. So moving forward to the criteria necessary for effective communication and the efficient communication. So you can see here we have three different criterias: performance, reliability, and the security. So we will see what is the performance. The performance is a measurement of various factors such as the amount of time required for the message to travel from one device to another. Time is required to get the response starting from an inquiry. Performance of a network, however, also depend upon the number of factors such as how many active users are there, what type of transmission medium you are using. If you are using fiber optics, then it will be much more faster. If you are using twisted cable, it will be the less one. The capacity of the connected hardware and the efficiency of the software. So all these factors were considered while considering the performance. So the network performance is very good if we have all these factors working efficiently. Okay. So performance measure is very important. What exactly we required is faster and faster communication. So performance is mainly how your message is traveling from one device to another device. And the factors coming on inside is how many active users are there, transmission medium, capacity of connected hardware, as well as the software. Moving forward to reliability. The network reliability is measured by frequency of failures. time it takes to recover from the failure. Okay, so if a network isn't reliable, it would be hard to transfer big data as the connection might lose in the midway and can make a longer delay can be expected. So only you will use the network if it is reliable. Now we are also using a network. We are moving from other network to geo network. Why we are moving from other network to geo network? Because it is giving you a reliability that my network is not will have a minimum failures, and it can be recovered if there are failures. So everybody will choose its data network. Like somebody can go for Reliance, somebody can go for Geo, somebody go for Idea. Now it is converted into a like uh, different company. So accordingly, performance wise, reliability wise, we choose a network. ठीक है, इसीलिए हम लोग क्या करते हैं, कोई भी नेटवर्क चूज करने के पहले उसकी रिलायबिलिटी देखते हैं. And the last one is security. How secure my network is. So the data can be sent through each to its destination safely without any third party reading or altering. That is very important. कोई मेरा डेटा डिस्ट्रॉय तो नहीं कर रहा है, या मेरा डेटा चेंज तो नहीं कर रहा है, या कोई रीड तो नहीं कर रहा है. So that safety measure has to be there. So this is called as a security. So my data is reaching to my destination same without any change or without reading by a third party. Then only you will call the network is secure. And if there are losses, it should be covered with the data losses. So this is all about the performance of a network. So we want high performing networks, means fast network without minimum delay. We want a reliable one, and reliable one in the sense that it will reach to the destination, and security that no third party is reading or altering or destroying my message. Okay, so on this performance only we will choose. So I will stop sharing my screen. So this is all about a part of your first unit. Is it clear to everybody? We just take the revision, whatever we have learned till now. We took one revision today. So okay, student,